go. You are perfect, Alice. Yeah. Here you can also see, originally I had links to these lovely different kinds of modelers. I don't have that, so instead I'm going to talk about the comparisons to real world examples, and later on, if we want to see clips of the videos that I've taken, I can do that, but for right now, I'm just going to get through the stuff that I actually have slides for. First of all, you've got freeform modelers. These are generally going to be your kind of most broad examples. So it's weird because sometimes people will talk about freeform modelers and talk about them as working with a lump of clay. The thing is, a lump of clay still has certain rules in how you manipulate it. A freeform modeler is more like if you took a paintbrush and were able to move in 3D with it. It's really powerful for things like texturing prints, but it can be a lot words. It can be a lot less effective for designing the whole build. I know a really popular one that's being used for texturing at the moment is ZBrush. What most designers who are using ZBrush will do is actually build the model in their preferred modeling software and then take it into ZBrush to give it all of its textures after the key modeling process. Next, we've got polygonal modelers. Polygonal modelers are that lump of clay. You're going to be doing a lot of manipulation of the parts by taking specific vertices on the object that you can set to be visible and stretching them to get the shape that you want. This has, depending on the program that you're using, different capabilities. I know that within Fusion 360, there's a whole mode that you can do for any type of solid modeling that you want to do in Fusion 360. They have a variant where it works on a freeform modeler. One of the really important things with freeform modeling is that freeform modeling basically goes directly against the principles of parametric modeling in that it does not let you just go back one step. I'll explain more of what that means in a bit, but one of the big things is that when you make a change, if you make change to other parts and then decide that you don't like that earlier change, you either have to undo everything that you've done or just go back and start trying to manipulate the part that was already manipulated to create the effect that you want. Next, we have solid modelers. Solid modelers work on a principle known as constructive solid geometry. A great way to think of this is that it's a lot like Lego bricks if you could build Lego bricks as triangles. A lot of constructive geometry is that you define a shape and then you are just bringing it up a certain amount. This is also where you get stuff like Boolean commands, where you are actually going to be using the interactions between two pieces to create a new piece. Surface modelers. Surface modelers are a fun one because a great way to think of them is a sheet. When you are building something, what you'll typically be doing is defining how that sheet is going to drape over something. Be it, I'm defining pentagons that are going to form a dodecahedron, better known as a D12. Or it can be, okay, I'm creating this shape and then I'm making it move on this path, and now I'm going to build that into an object and it will be the shape along that path. Parametric modelers are some of my favorites, and one of the cool things is that parametric modelers can encompass all of the other kinds of modelers. Biggest thing that separates a parametric modeler is that it has what's known as a history tree. The power of a history tree is that I am going to use an example that I think I've actually got a recording of me making. I was making something with text on it. I had the text. I decided I didn't like how another part looked. Rather than have to undo all of the text that I had designed, I just moved the timeline back so the program still knew that those future events existed, but for now was only listening to the events prior to a specific point that I've chosen. a lot of this makes not a whole lot of sense without actually seeing a 3D modeling program. We are going to open up Fusion 360 and go through some examples because, yeah, here we start to see that I didn't finish the presentation here. So I am going to pop into a 3D modeling program in a moment, but one of the really big things that you have to consider when designing for printing is the limitations of your material and your printer. Be that literally in terms of build space, how you approach a piece where, say, I have a piece that I'm working on where it is a giant neck cone. I had to cut that up into a bunch of different smaller pieces to allow me to actually be able to make it in future. Or it can be things like if you are working with a printer, it has a certain resolution that something has to be bigger than that in order to be made. It just, unfortunately, they don't have infinitely small areas. Yeah, I know for a fact that this one is my slide saying for other uses, and this is where I would talk about. As I said, this was not a fully complete presentation, so we are actually going to do now. Oh, I get to talk about file sources. I like talking about this. I will come back to the modeling process, but a big thing as well is that when you want to get into this, you don't have to start straight from, oh, I'm going to model this myself. You can look for files. Three of the most popular file sources where they have free options out there are Cults 3D, Thingiverse, and Printables. Thingiverse and Printables are very similar. One is managed by MakerBot, who is a 3D printer company. The other is managed by Prusa, also a 3D printing company. These files are not limited to use by only people who have that particular brand of printer. They do have certain things where, for example, from the printable site, there is a specific button that you can press that if you use Prusa Slicer, it will automatically send it into that slicer. It doesn't mean that you have to use a Prusa printer, but it is one of those things where it's a way of incentivizing people who are already using their product to keep using their sources.
If I might add, along with Thingiverse is another site called Fangs.
Yes, I don't use Fangs as often, but yeah, Fangs.
But Fangs is mostly links to other 3D printing sites, which can be a little sketchy sometimes.
Yeah. One of the biggest things is that there are things that you start picking up on, particularly when you want to be using something for a full-scale prop. Something that you start thinking about is how are these pieces going to connect together, as well as just little things about how is this going to be for me to actually finish the this file. I know for a fact that this just is not the best formatted slide right now, and I am going to. I can't use this computer without mouse. We're going to talk about some lovely sites. Here are some of the sites that I mentioned. Printables, as you can see here. Excuse me. Where did my mouse go? Printables. A lot of printable stuff is designed around different printers. One of the things to note is that with certain types of files, for example, you might see the bobblehead jack-o'-lantern. Depending on how it's designed to be put together, it might rely on you having a multi-material printer. Sometimes there are workarounds for that. Sometimes it just means that you have to paint it yourself if you don't have a multi-material printer. Thingiverse, very similar in that it's a file amalgamation site. One of the biggest things with a lot of these sites and a lot of when you're looking for cosplay specifically is that certain companies are a lot more litigious in terms of the files out there than others. I have a fantastic example of this. This is the Dangerous Ladies. They are a paid site. They are a Canadian-based company that focuses on creating cosplay-specific resources that people can buy. This comes in the form of 3D models, 3D printed kits, fabrics, whole host of things. One of my favorite things is that when you go into series, you will see here Western media, generic parodies. Now, there is a specific example that I am almost certain is in this file. You see a lot of things where you can probably recognize what character it's for, but it isn't labeled as that character. That's for a very specific reason. They have been copyright claimed for it, even though under the laws of fair use, this is a transformative fan work. There's disagreement on how legal it is, but there also, which is part of why these particular files aren't listed by the characters' names. There's a specific example in here that is one of my favorite examples of this. As you can see, a lot of different stuff. As you can see, Fiend Hunter Force. Nobody knows who that is. These are my favorite things. I don't know if anybody is a fan of the game Great Ace Attorney Chronicles. In order to get around copyright laws, Capcom made the decision to name a character who is a bumbling detective. Instead of being Sherlock Holmes, his name is Herlock Sholmes. They have had to list it back under Sherlock because Sherlock is technically not under copyright for them, whereas Herlock would be under copyright. So sometimes you get these funny things where a parody name ends up being parodied with the real name. This is my favorite example of that. It is also something that's worth considering if you are making files. Anything that you make for personal use, generally you're not going to run into issues for. The moment you start considering putting it out there for somebody else to buy, you have to consider things like, hey, is this going to be claimed by the studio or maker of the game? What are the policies around that? For example, Supergiant, the creators of Hades, has a very specific outline for fan-made merchandise, which includes resources for cosplay. If you are putting out files for Zagreus' sword, you have to make sure that you are limiting the number of times that can be sold so that you work under their specific policies. That's just my fun tangent on copyright law in 3D printing. The other source that I really love their files is Illustrious Models. One of the things that I will say is that it will depend on what you're looking for, who you look at for files. For example, I know that Dangerous Ladies has a lot of Fire Emblem weapons in a way that Illustrious Models doesn't necessarily. Illustrious Models has almost all of the key weapons from The Legend of Zelda Breath of the Wild. If I'm looking for, say, a light scale trident for myself to print off, I would go to Illustrious, not necessarily the Dangerous Ladies. That's actually what I did. I have an unfinished one sitting at my parents' house. And now I need to scooch over here. Now I'm going to talk a little bit more about 3D modeling software using Fusion 360. So, one of the first things that you'll notice about Fusion 360 compared to a lot of other softwares is that are different types of modeling that you can do. Most of the time, for making a 3D print, you are going to be working in solid modeling. Sometimes you may not be. For example, I think that this is a really effective example. And in general, the basis for any 3D print is going to be starting out with a sketch and then defining it from there. In this particular case, I'm using surface modeling to show how you might model up a die, because I think that's a fun one, and it's a really powerful example of what you can do with surface modeling, that sometimes surface modeling is more effective than solid modeling. For example, if I wanted to create just a plain six-sided die, that's really easy to do in solid modeling because it's just square, extrude, it's done. However, if you want to make something like a dodecahedron, that's really difficult in solid modeling because of the geometry of it. Whereas when you're working in surface modeling, all you need to do is, I need my keyboard again, and we are.
Let's just go with the 6.
Because I know the geometry math for 5, and I don't know it for 6.
Oh.
And I still need my mouse. Pro tip: don't accidentally break your keypad or touchpad when fixing your laptop. It makes it very difficult to use things. Nope.
Nice.
Yeah. Excuse me. Okay, we're working with 5mm. We're doing that. You can also set your units for what you prefer modeling in. I know that I work in centimeters a lot, but I've also learned how to model in inches depending on exactly what I'm working with. I'll change how I'm working with things. But we have our surface, and so now we're just going to finish sketch, and we are going to use patch, and we are going to select this, and we now have a surface. With this surface, we are going to choose modify, and we are actually going to do a move/copy. We're going to choose rotation. Our axis is going to be one of the edges. Excuse me, I would like it to be a body. You can see here that it's got a funky little create copy. What you're going to do there is create copy, select how you'd like that to move, and then you can just adjust how big the axis is. I really ought to just, 1 second. This is going to be so much easier if I just rather than constantly walking back and forth, why not just move where my laptop is? What a concept, right? From here, when I select the angle, let's say I want to do a 55-degree angle. That's not actually the angle you do for a dodecahedron, but it's an example one, and as you can see here, excuse me, it creates a fun little shape. One of the really important things when you're working with 3D models is just be patient. Like, it can be really frustrating at times, and especially when you're working on a bigger file, you can end up going back through and revising a lot of things so many times until you're happy, but you can end up with some really cool things. Rather than continuing on this, that doesn't feel like it has much of a point. I know there were questions about how to alter an STL earlier. I think that's one of the coolest things you can do. So we're actually going to create a new design, and what I'm going to do here is, nope. hold on a second, because I know that I've got... Sorry, I thought I was going to sneeze there, and then I didn't. Where the iron... somewhere. I think it might be in with... As you can see, I have not done a particularly good job of keeping my notes clear. I should probably try to do better than I have. Here's a fun one that I can demonstrate some stuff with. Load, please load. Welcome to a staff for Magical Girl Zelda. One of the really important things to recognize here, if I do this here, oh my gosh, you will notice here that, oh, I did actually have it saved with everything loaded in. Go me! When I show you bodies here, you will see a whole lot of bodies. And one of the things that I did specifically for helping how this would 3D print is that I designed this, that this loop with the Triforce in it is basically the exact size as my maximum on my 3D printer. As a result, I highly recommend when you're working with multiple bodies to not just leave them all named body, because body 16 does not mean much to anybody. Here you can see a fun one where if I zoom in and see this guy here, I can make it disappear. This is also a full one to show off because on the side here, if I turn off, I believe this is going to be... You can actually see here that where each of those parts go in, I've actually designed them to sit in there. As they print, it already has an inherent spot that it's going to sit. I don't know where my bell went, and I can't seem to get it to load into the program right now, which is frustrating, but we're going to try once more. There we go. There. Insert mesh. There we go. Welcome to the wild world of my 3D printing files. As you can see here, I have them sorted by series. In this particular case, I know the one that I'm wanting to reference is a Fire Emblem file. These definitely aren't characters that I plan on cosplaying or anything. Too many characters. How can you do this to me, Fire Emblem? As you can see here, I have actually already split this before, but it's fun to show you what it looks like. When you load an STL into your program, it's likely going to try to load in a weird way because it's going to just be based on some random set of values that you don't quite have. In this particular case, I can work with it where it's currently sitting, although I do want to show you that right now it looks fine, right? It looks normal. It's actually at a very weird angle when you start moving around. So, this is also a really cool thing where I can show you what history trees are. This down here at the bottom here is the history tree of Fusion 360. If I click on an action before, I can actually edit how I got something in, and you can actually alter, for example, here, you can alter the color, but you can also choose how something is selected. In this particular case, also, if you ever feel like you've lost your origin, it's probably because it's automatically turned off your origin. We are going to start out by, it can often help to rotate your different angles and see how it looks from multiple angles. It can be really confusing at times, particularly when you're working on a model that somebody else made, to try to understand things. In the interest of time, I'm going to come back to this later for those that are interested in getting more into the 3D modeling, and I'm going to talk a bit more on, once you have your file, how you go about slicing it, just because I don't want to keep everybody here for too long. For talking about slicing, slicing is a bit of a weird thing because there's a lot of terminology that slowly, as you start using it, you learn more about what it means. Here, this here is my slicer. A slicer is any software that turns your model, be it an object or a stepil, I can never remember what's called.
STL.
Yeah, it's a full name, but STLs. Basically, these, either an object or an STL, exist as a wire mesh of shapes. A slicer is going to convert that into an actual manufacturable thing. It usually, depending on the type of program, depending on your type of printer, it will output a file that is used to create the object. In the case of most 3D printers that use filament, it's going to be a G code where it is basically going to be a path for your nozzle to travel to create your whole thing. In the case of resin slicers, they're a little bit different in that what they do is generate a series of images that will be exposed to create your object. This is also part of why resin printing is usually so much finer in its resolution than filament printing, because how much you move up in a resin print has to be more limited because it is tiny layers being exposed to UV light and then moving, as opposed to blob of plastic moving around. Anatomy of a slicer. You're going to have somewhere your print settings of what type of filament you're using, what printer you're on, what print settings you're using in terms of what size is it working with. I really like Prusa Slicer, 1, because I have a Prusa, 2, because they have done a really good job with presets. I also run on Cura from time to time, and the big thing that I find with Cura is that you can absolutely find amazing profiles out there for people who have already created it. The issue there is that 3D printing is a little bit of a weird thing because it is simultaneously a tool to allow you to create what you want to, and a hobby all on its own. There are a lot of people where their hobby is in fact tinkering with their printer to get it to be as fast as possible, as high quality as possible. How can they change the firmware that it runs on so that it does exactly what they want it to? If you've ever seen a time lapse that somebody has taken of them 3D printing, they have likely included a very specific code, particularly if it is one where it just shows the object rising with no nozzle in the way. They have likely installed specific software to move the nozzle out of the way after it registers every completion of a layer. This can have its own issues in terms of how stuff sticks together and is often a cause for failure, but it is a thing that can be done. In the case of Prusa Slicer, there's a lot of presets. The biggest thing around why you choose your filament is that filaments have different temperature ranges depending on the food. So a good way of thinking of it, because there are 3 really common ones that you'll end up seeing, 4 if you count TPU. The 3 common filaments that you end up hearing about are ABS, PLA, PETG, and TPU. Each of them has its own benefits and downsides. One of the biggest ones to ABS, if you've ever worked in any sort of construction site, is probably diesel. The biggest thing is that it's really easy to bond ABS to another piece of ABS because guess what melts ABS? Acetone. Like the same stuff that you use on your nail polish? Yeah, it melts ABS. Flip side is ABS lets out a lot of really toxic chemicals, so if you are using ABS, you have to take more precautions. The most common one that you see most things, particularly for cosplay, printed in is PLA. Depending on the exact formulation of words, depending on the exact formulation a brand is using, you can get a lot of different benefits from PLA, and it will vary brand to brand on how high quality people find they are. With that, it is really important to recognize that once you are printing, if you are struggling with getting a specific roll of filament to work, first step is check for settings. The second is, okay, my settings are right for the filament. Filament is still not working. Filament, because of how it is made, is actually incredibly prone to absorbing water. As it absorbs water and moisture from the air, it becomes less effective because part of that heating is not only going to heating up the plastic, but boiling off that water, which creates air bubbles and can cause issues. PETG has a lot of really similar properties to PLA. One of the things that I've really found is that PETG is far more reliable when you're looking to print something that will be transparent than PLA. There's a lot of finagling that you can do when you're looking for a perfectly clear print. Something that I have not personally gone into, but there's a lot of stuff that you can do to try to get a perfectly clear print as opposed to just something that will let light diffuse through it. And depending on what you're looking for, there are different resources out there. And finally, the last filament I'm going to touch on is called TPU. TPU is fun because it is actually a rubberized filament, so it's designed to be much softer and much stretchier. The issue with it being a rubberized filament, it is a lot harder to print and has a tendency to clog nozzles. It is one of those things where if you have something that needs TPU, you're definitely going to put the work into it, but generally speaking, for most cosplay things, you're likely just going to be using PLA. Now, I also want to mention here that when it comes to printing, let's say I'm printing a sword. The thing about 3D printing is that it is simultaneously incredibly strong and incredibly weak. Because when put under tension or compression, filament printing is incredibly strong. With shear forces, it is not strong because it inherently has weaknesses along those layer lines. Typically, if you're printing something like a sword, what you're going to want to have is some sort of support, usually either a metal or wood rod that sits in it to add weight and also stability. And for an idea of how strong it can get if you add those supports, I was commissioned to print off a Buster sword. It comes to here. It is, I think, an inch shorter than I am. I have a video somewhere of me actually picking up the sword and swinging it around like a helicopter blade with one hand, and then I accidentally had it slam into the grass because I was doing this outside. Most of the sword is completely intact, except for one part where it didn't have quite a strong enough bond at the tip, and it didn't have enough of the support running through it. So that just broke clean off at the connection point. If you're looking for smaller details, a great example of this is, have you ever seen a Genshin character? A lot of their costumes have really finicky little bits on them for those kind of fine detail things. For that, you're likely going to start wanting to look at a resin printer. It's one of those things where when looking at what type of printer to get, a big thing is going to be looking at what do you want to make. If you want to make armor pieces or swords or fine detail bits, each of those is going to change what you look for in a printer. What else do I need to say about 3D printing? I don't want to get too into the specifics of any one machine because a lot of how something 3D prints is going to really heavily depend on the machine. What I am going to talk about, however, is some of the stuff on finishing. If you have a thing that you've put together, first of all, if you're looking to put stuff together, if you need it to make a strong bond that is in a spot where there's going to be a lot of friction or you need it to hold together, use a two-part epoxy. Usually one that cures within 5 minutes is going to be your best bet. You will end up finding that it'll vary what you need. Supports are a big one there. And then let's say that I've got a small detail. For example, the Buster sword. I'm going to put together all the parts of it using a two-part epoxy. Gluing the materia on, part that is never going to be under stress and has a little divot, I'm just going to use cryacrylic, better known as super glue. I personally, I can pull out my favorite one. Personally, when it comes to putting together 3D prints, I like a Gorilla Glue gel. Specifically the gel because it's a slightly thicker formula, so it helps with how things are bonding together. And the biggest thing is that you'll know that a 3D print has a pretty good bond when you actually see the words. Sorry, it's a long day. One of the biggest things that you'll notice with the bonds that you're making in 3D prints is that you want to see a little bit of the plastic melting into one another. One of the other things you can do is if you have a spare soldering iron that you don't mind getting messed up and a well-ventilated area to work in, cannot stress those two things enough. You can actually do what's sometimes referred to as plastic welding, where you use the filament and soldering iron to actually use the same principles as you would with welding to put the pieces together around the outside. This is really powerful for the outer layer, keeping that bonded together, but may not be as effective for inner layers, particularly if you've got a piece that has a lot of strain that may be happening to it. Using a combination of glue and plastic is really powerful. The last bit I want to talk about is, where did my mouse go? Finishing. A lot of this I'm referencing the Dangerous Ladies Guide to Finishing. Fantastic blog post for this. They have a bunch of resources that they're putting out for these. But as well, if you want to get a hands-on example of it, I will be doing some hands-on 3D printing finishing tomorrow. I'll be in the North Lobby. Come and join me. I've got a mix of some FDM prints and some resin prints if you'd like to get the sense of what the difference between the two are. But a big thing is that whenever you're working on your finishing, you have two main things that you're going to want to do. Stick the parts together and then clean up layer lines. It's really, or rather, clean up support lines and layer lines. It's important to note that part of this also refers to resin printing, because even though the layer lines are a lot less noticeable, layer lines do still exist in resin printing, just due to the fact that inherently these are methods that are additive. For an idea of that, does anybody not know the difference between additive and detractive manufacturing? Also, I love answering this. So the principles of it are detractive modeling or manufacturing usually. So a great example would be if you take a cube of metal and then slowly plane away at it. The most common application that you'll typically see is something like CNC machines, where they actually use guided paths to cut away material to get what your end result. That's an example of that. Additive means that you are slowly building up your layers. They have their advantages and disadvantages. One of the biggest things around additive manufacturing is that you only use the materials that exist for the product or were needed to get the final product. In a lot of the others, like the CNCing, you end up with a lot of excess materials.
Does everyone know what a CNC machine is?
CNC is a specific type of carving machine that works with a variety of materials. A great way of thinking of one that uses similar principles while not being as powerful than you see a lot more in home uses is like a Cricut or vinyl plotter, where you've got a sheet of material, you cut out the parts that you want, you have excess left over. Yeah. And so for the last bits on finishing, a big thing is that when working with 3D prints and finishing them, you want to get a combination of smoothing and filling in layer lines. So the most common techniques that you're going to see are using some sort of additive filler, be it spray-on automotive filler, wood filler, spackle. Bondo is a really common one, but Bondo carries a lot more safety concerns, so depending on what you are looking for, if you're looking for a piece that's going to be taking a lot of abuse, Bondo is probably the way to go. If it's a piece that's not going to be hit a whole lot, generally going with wood filler is going to be fine. As well, something to consider there is that wood filler you can clean up with water, so it's a lot easier to do in a smaller setting, in a home setting, than it is Bondo, where you have to use solvents to clean. It is also worth noting, if you have used any sort of filler primer, any sort of fillers, when it comes to your painting, do a test patch first to ensure that you're not going to have a bad reaction to the underlayers, because it really sucks to have a bad reaction when you get to the painting stage and have to come back and completely redo your finishing. Yeah, I would put up a slide for questions, but are there any other questions?
Is it possible to use acetone on PLA, or is it only ETG?
So the thing about trying to use acetone on PLA is that, so the reason why the acetone fusing and like smoothing works on ABS is that acetone actually has a chemical reaction with the ABS. Unfortunately, PLA is considered to be a very unreactive plastic, which is part of why it's really safe to print it. You don't have to worry so much about things like enclosures, like ventilation-wise. As long as the room has ventilation, it's not as big of a concern. Whereas ABS, you have to have an enclosure. You need to make sure that the fumes are being extracted, because it is a very toxic fumes that are released. Unfortunately, it doesn't have that chemical reaction. There are products out there that have been specifically formulated to have that kind of chemical reaction with PLA to help you be able to bond it together, or to be able to do that chemical smoothing. Yeah.
Personally, what is your favorite printer?
Now, I definitely have a bias because I've used a few different ones, and I've seen a lot of the evolution of 3D printers. Of the first printer I ever worked on was a MakerBot. I know that personally, the biggest things that I look for in a printer are I am a lot more bigger of a fan of printers that move the nozzle up and then move the bed on XY as opposed to the nozzle stays at the same height level and the bed moves down. Uh, that's just based off of what I've seen in terms of failure rates. I know that some of the most popular printers out there at the moment, I know that the bamboo is really popular at the moment, in part because if you're looking for fast, it's really effective. It carries a lot of cost. Usually, with printers, what you're going to end up finding is that it has the inevitable triangle of life of do you want it to be fast, inexpensive, or reliable? You can only pick two of the three. Something that is inexpensive, fast. Something that's inexpensive and fast will not be reliable. Something that's expensive and fast. Actually, no. Depending on your budget, there do exist machines that are fast and reliable, but they are very expensive, and so it will just be that inevitable thing of if you want fast and reliable, you gotta pay for it. If you want inexpensive and fast, it won't be reliable. If you want inexpensive and reliable, it's not going to be fast, or it's going to require a lot more input from you to keep it up to date. A big thing that isn't talked as much about is actually the maintenance of the printer, because that's a big factor when you're actually getting into printing things, is that you have wear and tear on the machine. For those who are based in Kelowna and are interested in getting into 3D printing, there are actually programs through the library where you can use FDM printers for free or relatively low cost. So they're a great way of getting a sense of how some of that stuff goes, particularly if you have small little models that you want to try out with. Otherwise, if you have a file and don't yet have a printer and just want to get it done before making that investment in getting a printer yourself, there are services out there where you can actually get somebody to print all the file for you, be it something that you made or purchased. I know that I've been commissioned on a few different occasions to print off a file, and then I just gave the printed parts to the person that commissioned me, and they did all of the finishing themselves. Yeah, otherwise, for where you can find me, I'm not going to bother bringing anything up, but you can find me tomorrow at a few different panels, and I will have my information up there. Otherwise, I can be found with Savior Cosplay anywhere online. I don't know why I'm in caps lock, but hi, yes. I am one half of Savior Cosplay. This is Facebook page for it. As you can see, I've totally posted here recently. Totally don't forget to cross-post from Instagram at all. But yeah, otherwise, we are getting pretty close to the time when this is all over, so it was great having everybody out. Thanks so much for coming out. If you ever have questions about stuff, please feel free to reach out to me. I love trying to be helpful, and yeah.
Thank you.
Yeah, thank you.